two material scientists, one expert in memory devices and one expert in chemical deposition, meet two scientists working for the worldwide leader industry memory technology, they might decide to face the future scaling of memory devices by working together in a European project. This is what happened in the Chemaph project, which stands for Chemical Vapor Deposition of Chalcogenide Materials for Phase Change Memories. This project is about the scaling of non-volatile memories to reduce cost and increase performances by using a novel approach based on phase change materials. Phase change materials are alloys based on one chalcogenide element and are able to fast switch between two different resistive states related to the amorphous and crystalline phases of the material. The switching can be sustained by proper current pulses. Such devices are called phase change memories. To allow the scaling down of device dimensions, the chalcogenide material should be grown inside very tiny structures with high uniformity. A deposition technique alternative to physical vapor deposition is therefore required. In the project, we focused on metal-organic chemical vapor deposition, also called MOCVD, where the vapor phase transport is obtained by metal-organic compounds of the atomic species to be deposited. The Chemaph project was carried out by a consortium formed by 6 partners, including 1 academic, 2 national laboratories and 3 industries. Epichem, now SAFC ITech, was founded in 1983 to supply high-purity chemicals and gases to the semiconductor industry. SAFC is the precursor supplier for the Chemaph project. Ekstrom, based in Germany, for more than 20 years has led the development of systems for the epitaxial growth of complex thin films. Ekstrom is the industrial-grade metal-organic chemical vapor deposition equipment supplier for the Chemaph project. Vilnius University is the largest institution for science and education in Lithuania. The MOCVD laboratory belongs to the Department of General and Inorganic Chemistry. During the Chemaph project, Vilnius University developed hot wire liquid injection chemical vapor deposition of chalcogenide materials. The Consejo Superior de Investigaciones Científicas is the largest multidisciplinary public research organization in Spain. As early as in 1992, CSIC researchers in Madrid demonstrated femtosecond laser-induced crystallization and reamorphization of chalcogenide materials. A wide range of laser sources are used during the Chemaph project, covering the spectral range from the UV to the near-infrared and delivering either nanosecond or femtopicosecond laser pulses. ST Microelectronics is a leader in developing and delivering semiconductor solutions across the spectrum of microelectronics applications. The Chemaph activities, including demonstrator development and testing, were supported by ST Microelectronics in the R2 Research Center in Agrate Brianza. R2 now belongs to Micron and is the most advanced center for the development and early production of new generation non-volatile memories. The MDM laboratory belongs to the Italian National Research Council and is hosted in the ST Microelectronics site of Agrate Brianza. Characterization facilities include X-ray photoelectron spectroscopy, electron spin resonance, scanning probes, X-ray diffraction, electrical characterization, optical spectroscopies. Atomic layer deposition facilities are located inside a 94 square meter class 1000 clean room. The laboratory includes a yellow room for UV lithography and wet benches for device processing. Thermal and E-beam evaporators, scanning electron microscopy, and rapid thermal processing complete the process facilities. The main achievements of the Chemaph project include the demonstration of CVD process for chalcogenide-based thin films, the evaluation of phase change memory demonstrators, including MOCVD chalcogenide materials, the development of modified compounds to improve the performances of the cells.
The role of our MOCVD system within the Chemaph project was to study the growth of germanium antimony telluric binary and ternary alloys, aiming to obtain phase change materials comparable to what obtained with sputtering and trying to improve the deposition conformality, that means uniformity, within structured substrates. During the project, a laboratory fully devoted to the deposition and characterization of chalcogenide materials was set up at MDM. In particular, an Eichstron MOCVD reactor, which does not use dangerous gases, was installed. The equipment was dedicated to the growth of thin germanium, antimony and tellurium alloy layers on 4-inch substrates.
The chemical composition of the deposited chalcogenide materials was measured by total reflection X-ray fluorescence analysis in a system especially designed for this purpose. In germanium antimony telluride, generally called GST, the chemical ratio was precisely evaluated. The crystallographic structure was probed by X-ray diffraction in grazing incidence geometry. The phase transition from amorphous to crystalline, corresponding to the 0,1 of a memory cell, was followed by resistivity measurements as a function of temperature using the Van der Poel configuration.
The best results in terms of device performances were obtained with GST deposited by hot wire chemical vapor deposition at Vilnius University. In the pure spirit of a European collaboration, the cells were first prepared in Italy by ST Microelectronics, sent to the University of Vilnius for chalcogenide deposition, sent back to MDM for device finishing, and finally moved to ST Microelectronics for device testing. Programming performances as good as those obtained using Spatter GST were reached within the project. Phase cycling was also demonstrated in alternative chalcogenide materials, opening new perspectives for device improvement.
The Chemaph project constituted the first step toward the development of MOCVD-grown chalcogenide materials for memory devices. More steps are needed to reach their development and full integration, but it's only by working in close contact between academic and industry that such an ambitious goal can finally be reached.
Dun 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 dun.